Okay. So today's lesson is this is a new lesson in illustrative mathematics, the IM curriculum that we walk through. This lesson is lesson number 9. I have not yet posted in the Google Classroom, but the learning target of today is just to understand what is logarithm. And if you see on the on your calculators, my question, everybody see a calculator? Open your, check your calculator. Do you see this log? Yes or no? So the first thing is, what is this log, right? Do you see log there? So far, some of you may know how to use it, but maybe some of you know I don't know how to use it. So that's log. So our goal is, what is this log? Okay. So the learning target is basically what is logarithm. Let's go with straight away what we already know from exponential. So here we have a chart, I think, and this is the input output. So the input, so I'll start with the 0 first, okay? Let me not go, or we'll start with from the bottom part. Now when I plug in the blue color, base that I took is 2. So this base we already know. So this is input and that's output, right? So plug in 4, and if I plug in 4 here, what do you get here? So let me write here, what answer do you get? So y. So y, can you write down? So as I write, just make sure you also take note of this. So it's the blue color 2, the base, raised to the red color 4. Do you see, Mia? So what's the input there? Is the input 2 or input 4? 4, right? So that's 4. So what value does 2 raised to 4 give? Let's you. What is the value of that? 604? 64? She's saying 64. Do you guys agree? Okay, check it out. 2 raised to the power 4. What is that? Ahuda, would you have to share? 16? Nicole, 16? 2 times 2 times 2 times 2. So what does that 2 raised to 4 basically mean? How many times the base is multiplied? The exponent, this 4 means how many times do you multiply? So let me see, this is where we get confused. So what is 2 raised to 4 means? You multiply 2, how many times? 4 times, right? This is 4, this is 4, and 4 times 4 is 16. Agree, yes or no? Okay. So this answer, I'm going to write the green color 16. Is that okay? Can you tell me directly what should be this one then? If it is 3. So what is 2 raised to 3? Is it 6? I heard my one class saying, Mr. Jacob, if the input is 3, the output is y equals the green base. See, I'm always using the green base because that's the growth factor, how you multiply to the input raised to the 4, right? Oh, so not 4. This time what I'm using? 3. What is that answer? So what do you get here? 2 multiplied by 2 multiplied by 2. 8? She's saying 8. You guys agree? Okay, let's go directly. So I'm moving. So can we do it now faster now, quickly? How the numbers will work? What will be our output now? So if it is y equals, if the input is the 2, the output will be 2 raised to the red 3, red 2, sorry, and 2 times 2 will be 4. Agree? Yes or no? Nobody is saying yes. Is this making sense to you? And we are going to graph also. See, it's beautiful, the grid that I've made is, once we finish this, we'll graph that, okay? What about 1? So y equals the blue 2 raised to the red 1. 2 raised to 1 is how much is that? How many times do you multiply 2? Just 1, so 2, right? So are you getting what I'm doing? Because what about 0? If the input is 0, so these are all x's, right? So y equals the 2 raised to 0. Anybody knows what that means? Anything raised to 0 is what? Is it so? Is it 0? So you said 0 too, or is it 1? So is it 0 or 1? Get confused? Watch. Why? What's so? Do you see every time in this case you multiply by 2? How do you get this 2? See, look at this. There's a 2 to 4, right? So you kind of multiply. So this part you multiply 2. 2 times 1 is 2. 2 times 2. Every time what are you multiplying here? 2 times 2 is. Sorry, 2 times 1 is 2. 2 times 2 is 4. Then here again you multiply. In other words, how do you, sorry, I think I confused you. So each time you're not multiplying this number. So every time you multiply 2, 2 times 2 is 4. You multiply 2 one more time, 8. You multiply one more time, okay, 16. But then if I want to go back, what do I do? Do I multiply 2? Do you multiply 2? See this, the pattern here, 2 times 2 is 4, right? 4 times 2 is 8, correct? 8 times 2 is 16, agree? But I want to know what is this, right? So what do you think was here? 1. Did you get that part? So this has to be 1. So I'm putting this equals is 1. So we also learn why it is because you are dividing by what? Instead of multiplying, here you are dividing by. So here you are dividing by 2, got it? You undo. So 2 raised to the power 0. What about the next one here? If this is 1, y equals 2 raised to, now the input is -1, so I'll put a minus red 1. Equals, what is the answer here? Nicole. Say it again. What is it? Two raised to the power negative. We did this long back and we forget, right? See, what is 2 raised to 1 means? 2. So you say it is -2? Okay, let's go this way. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 1. 1 divided by, so what is 1 divided by 2? 1/2, correct? So kind of, oh, that's how you get 1/2. So basically you just do the reciprocal of whatever you have here, you just like that. Make sense, Nicole? Your eyes are lighting up now. Your eyes, they are lighting up. Means you kind of, oh, now I get it. Do you feel that little? No, nothing so far. Okay. So what about the next one is, let's do, now I'm gonna little go fast, okay? This is the main thing, and then the rest follows. So y is the blue 2 raised to -2. What is the answer? 1/4, correct? Because 2 raised to 2, look at this, 2 raised to 2 is 4, but if there is a minus, then it flips. So it is 1 over 2 times 2, which is 1 over 4. Is that okay? Let's graph this. Let's graph this quickly on your grid. I'm going to start with the first one is minus 2 is 1/4. So minus 2 right here, 1/4 is here. Look at this. Is that okay? So this is minus 2 1/4. This part is minus 1/2. Then it is 0 1. This is 0 1. 1 is 2. Nobody's saying yes. Can I hear what is 2 is 4? So 2 is 4. And 3 is 8. 8 is right here. Oh, this part is over here. So 2 is 4. 3 is 8 right here. 3 is 8. And you can see that we did this, but still I thought of showing again. And there's this graph, exponential graph. You start from left, goes all the way through this point. See, rising up, exponential function y equals 2 raised to x. Now what we want to do is just flip this. So I want you to do is make a table on the right side, make another table quickly. Okay. Okay. If the question is asked, what about if there was the output here was 128? So if there was an output 1 to 8. So what should be the input? So questions arises if the output is 128. So how many times, see we had a factor 2, right? So all the time we were just multiplying 2, 2, 2, 2s. So you're just asking a question, how many times do you multiply 2 to get to 128? So for that, so the mathematician decided, hey, is there a way out what to do? How do we create a function? This is y equals 2 raised to x. What the mathematician says, okay, let's flip this. So the input output becomes output input. So that means this 1/4, okay, this 1/4 is written down here, 1/4, 1/2, 1, 2, 4, 8, and 16. Got it? So the output is written as input, and the input is written as output. So this will be minus 2, minus 1, 0, 1, 2, 3. And then 128, let me write it here. 1, 2, 8. Is that okay? So you just flip it. So the mathematician, Mia, you know there was one guy, his name was Logarithm. What was his name? Logarithm. His name is Logarithm. So what he said, okay, I'm going to use my first 3 letters of the logarithm, log. You see that the calculator log, yes or no? So he said, okay, let me build up my own function kind of thing. So this is xy. When you flip this, this flips. Watch this. How do we write this? So this x will be, see this one? This is x, okay, equals, so what x equals, the blue 2 raised to the black y. Nobody say yes or no. You see this what I did here? Why did I write this? This was y is 2 raised to x, correct? Now what I did, yeah, I just flipped this. Because this column and this column is just flipped. So because they flipped that way, so I have to change this as, I have to also flip this letters x and y. Do you see that? And it makes sense also. Look at the, so the x is, this is x now. This is the orange y. Only thing I wanted to make sure that this input, I don't want you to write 1 second. There's something is going wrong. I want to make sure I'm doing it correct. Yeah. So, did I put the colors? The black one is the where X I'm using, okay, those colors. The Y is the black. Something is going wrong there. I want to make sure this is correct also. Okay, so X I think I messed up the colors. Yeah, the output is bad and the input is the red. I made it like an orange there. So okay, I don't want you to, I won't put the colors here because that's, let's see what I'm saying is, this is x equals 2 raised to y, okay? But I want to make sure we get it correct. So let's see, and you can clearly see, you can take one example of 2. Let's see, if I put a y is 2, this is y, right? If I put y is 2, 2 times 2 is 4, and that is x. Do you see that part? So this is really true. So only thing, I can still write that, yeah, this could be the green x, let's put it like x, the green x. And the other one you can put as the y. I'm just showing that part. The goal here is just to make you understand, hey, what is the meaning of now? So if you want to know, if I ask you, let's ask a question. I put a question here. If the input is 128, so we want to know why. We want to create a function here. Why is something here? Why is something there? Watch this. I'm gonna finish this quickly because this is the most important. How do we get from 8 to 3? Easy. Just remember over there, what did we do? We take the base and you ask a question, how many times do I multiply 2 to get to 8, right? And you said 3. 2 times 2 times 2 easy. How many times do I multiply 2 to get to 16? 4. Do you agree? How many times do I multiply 2 to get to 4? So basically you're asking a question all the time. It means, suppose I want to write how many times do I multiply 2, the base 2, to get to, let's say 8. I'm just taking 8. Can you see the answer? Abhi, 1 second, I'm finishing. So how many times? So basically, every time you're asking a question at the left side, asking, hey, how many times do you multiply 2 to get 8? You say 3. How many times do you multiply 2 to get to 16? 4. Do you get what I'm saying? How many times do I multiply 2 to get to 4? 2. How many times do I multiply 2 to get to 2? You see how much? So many words. Instead of writing so many words, the mathematician said, okay, let me just put log. See that? So this is how I'm ending my class, just to show how it started. So he said, okay, that's too much of work to write. He just put 2 at the bottom, called base, and then put a parenthesis to say, which number are you talking about, the green numbers. And the green number is, we say, okay, 8. Can you see that? And the answer is what? What answer did we get? 8? Agree? Nobody saying yes. So what is this big log? Stupid, I call it stupid sometimes because right now for you it is first time, right? So log of to the base 2 of 8, basically just asking the question, how many times the factor 2 has to be multiplied to get all the way to 8. Make sense? Nobody saying yes. So I'm going to put one more last question and then we'll graph this. I ask you and to make sense. Suppose I write log to the base 5. I'm putting a 5 like a factor. What is that 5 multiplied? And I write 25. Can you tell me what is this answer? All of you tell me. What does this mean? How many times do you multiply what? 5 to get back to what? So how many times do you multiply 5? 5 times? 5 times? 5 times? No, my question is 5 times 5 is 25. But how many 5s did you multiply? 2. That's good. Do you see how it works? That's all log means. So what is logarithm means is just checking on how many times do you multiply the base to get that. Make sense? How many of you are getting? It will take a little while. Today was just a beginning and next class I will show. So my goal was just to understand the fundamental, oh, that's logarithm and we can easily graph this. Once you see, I'm gonna, when you flip 0, 1 is this one, because of the time I'm going quickly. 1, 2 is 2, 1, so I go back to 1. This is 2, 4, I go 4, 2. See the how, this will be 2, 1 here. This will be 4, 2. And this 3, 8 becomes 8, 3. This minus half will be half minus 1. This will be like, and you get a graph, like, look at this graph. Do you see the graph? They are kind of a reflection. If you draw a line, y equals, if I draw a line, y is x all the time. See, what is y equals to x means every time x coordinate, y coordinate is the same. You see? And from geometry, you know that. So the graph, the green graph is the reflection of the orange graph. Do you see that? So you just flip it. Basically, xy becomes yx kind of. It's just flipping the coordinates. It is 1, 2 becomes 2, 1. 2, 4 is 4, 2. 3, 8 is 8, 3. Do you see that flipping? Nobody say yes. Are you guys getting something, right? So what is the learning here today is only to understand what the heck is this log of means. So log means just asking a question is how many times do you multiply the base, whatever the factor is, in order to get all the way to 25. Make sense, Sarah? Are you okay? Mariana? So that's all I wanted to show, and we will go deeper, dive deeper into this more on Monday, kind of, you know, because we have laws of, there are some 5, 6 laws of logarithm, some properties to make you understand too much deeper into this and maths. Is that okay? My question is, before I wind up, did you get something? I know it's the first day and logarithm is confusing. But if you can understand this, oh, this is exponential, just flip it, that's it. And that's the mathematician, he said, hey, put my name. He said logarithm of the input here is x and the base that you use is 2. See this new thing? That's like a kind of a new function, logarithmic function. So what is logarithmic function is logarithmic of 2 the base 2 of x, and whatever that is, I can put a gx. And this one I could have called f of x. The original is f of x, and going back inverse, so that's also going to be called inverse, means you get back, undo. Whatever you did for exponential, you undo. Am I making sense? Because nobody's saying yes. I know I went a little fast. I know I confused you. In between, I got lost with the color coding. Just forget, don't get too much into, because I did not really plan well. But goal is flip it, and then that's it. And then you're done. Okay. So anyway, so we'll do this more on the next class as go deeper into that. Today I just wanted to know what is this. That's what I wanted. The logarithmic of the number to the base. Yes, you have a question? On the computer? Calculator, you have to go to the maths, click on the maths. Okay, I'll show you. Very good question. If you click on here, can you see this log there? But this log, basically the base is 10. It's like, instead of 2 it is 10. But if you want to get exactly 3, 4 like that, you have to click on maths. Can you click on maths? Everybody click on maths and scroll down. Do you see somewhere log of something like this? I think. Yeah, to the base. It says, yeah, log base. Does it say log base? So it says log base like that. Click on it, and you see that those things popping up there. Log base. Oh, this one is different than in my